Prep. So guys, as you know, yesterday we were having the welding session where we discussed around 10 questions for the welding. So guys, today we are going to have the second topic, and today's topic is metal casting. So today's topic is, my dear, metal casting. So my dear, when we are talking about this metal casting, this is also very important topic. As far as GATE exam is concerned, the weightage for GATE exam for metal casting is going to be approximately 2 to 3 marks. So here we can expect, my dear, one numerical and one theory question. These are the expectations. Okay. So even we can have 2 numericals as well, 2 theory questions as well. So both possibilities are there. So guys, please tell me, am I properly audible and visible to all of you or not? Then we are going to start the questions one by one. Okay. So moving further, guys. So this is some detail about me. I am having around 10 plus years of experience, and subject is production, which is the highest weighted subject. Then, my dear, it is a very important announcement for all those students who want to prepare for GATE 2024 or 2025. You guys are having a scholarship test on 30th of July. To avoid the time bar, we are keeping the time from 9 a.m. to 9 p.m. You have these 12 hours. In between, whenever you get the time, you can go for the test, and you will be getting up to 90% of the scholarship on to the GATE preparation programs. Okay. So that is a very good opportunity for all of you guys. Okay. So the date for that is 30th July. Moving further, guys, on Thursday, today is Tuesday. So day after tomorrow at 11:15, we are having this session of how much maximum you can score if you are starting your preparation today. Today means if you are starting now, obviously it is late because you are starting at the end of July. So what maximum you can score? Me and Abhinav sir would be joining and will be taking this session live. So guys, this is the very first question in front of you from the metal casting. So first of all, I would like to tell you what are the topics from which questions are asked from this topic. So in the metal casting, questions are coming from riser design, questions are coming from gating system design, they are coming from gating ratio, they are coming from slush casting, centrifugal casting. All these are the topic from which numericals are framed. Otherwise, for theory, there is no limit. You can have many theory questions possible. So we are taking these numericals. A casting of cubical shape structure is required with 60 mm side. Okay, this is the size of casting. Then they are saying, assume volume shrinkage of casting as 2.3%. If the height of the side riser is 30 mm and riser volume is 4 times the shrinkage volume, then find out the appropriate riser diameter. So if you see this question, my dear, this is from shrinkage volume method. This is from shrinkage volume method. If you remember, there are many methods. Okay, there are many methods for riser design. We were having Kane's law, Chvorinov method, shrinkage volume method. We are having some other methods like one method is that is modulus method. So out of this method is shrinkage volume method. And nowadays, if you see recent GATE, in the recent GATE, they are asking from either this, or they are also asking from one more, that is the shape factor method. So for nowadays recent GATE, they are important topics. So here we are having two conditions. First condition, what we are saying is the necessary condition. So for necessary condition, they have given you something. But if you see here, we will say that the volume of riser is going to be more than or equals to 3 times of shrinkage volume. But here they have given the 4 times. So 4 is more than 3 only, you know that. So my dear, first of all, we need to find out the volume of casting. So when you will say volume of casting, casting is of cubical shape. So it is going to be 60 ka cube. And my dear, if you want to find out the shrinkage volume, so they have given that what is the shrinkage volume. Shrinkage volume is given as they have mentioned it 2.3%, my dear. So you will say it is 2.3 divided by 100 into 60 ka cube. I feel when you will be finding out the shrinkage volume, I have calculated it 4968 mm cube. 4968 mm cube. So now, my dear, the necessary condition says that the volume of riser pi by 4 d square h. This is the volume of riser. That should be more than equals to, for our case, it is not 3, it is 4. So it is going to be 4 into 4968. When you will put this value, my dear, you will get diameter because height is given in the question. Okay, Kiran have already solved it. 28.34 is the answer. So Kiran is saying answer is C. Yes, Kiran, good evening. So for the first question, you are saying the answer to be C. Okay. So let us see. So you will be getting from here as like you are saying 28.34. But I feel, Kiran, you forget that we are also going to check with the sufficient condition. So you need to check with the sufficient condition. What is the sufficient condition? What is the sufficient condition? Sufficient condition is the modulus of riser should be more than equals to modulus of casting. So when we are talking about the modulus of riser, it is volume by surface area of riser should be more than equals to volume by surface area of casting. So my dear, when you will be going for this, Kiran, please tell me, are you getting the same answer or the answer will change? You know, volume of the riser is pi by 4 d square h. When we are talking about surface area, it is pi by 4 d square. Have they mentioned which type of riser it is? Have they mentioned? They are saying assume, okay, is required. They are just saying the side riser. So for the side riser, we will be having 2 times pi by 4 d square plus pi dh. Height is given to us, and when you will be equating this with the a cube by 6a square. Yes, very good. Side is given to us. This time you will be getting diameter will be coming out to be more than equals to what? I feel it will be coming 120 mm. So you will be getting the answer to be 120 mm. So yes, so you know that sufficient condition requires 120. So if sufficient condition is saying 120 and desired is saying this 28, the answer is going to be 120 because both the conditions must be satisfied. So very good, Kiran. The answer for this question will be D. Moving to the next question, guys. Moving to the next question. This is from the slush casting. On the slush casting, till date, questions have not been asked in the paper. So we have chances that question will come this year from the slush casting because they have already asked from the centrifugal casting. So next number will be for the slush casting. So they are saying the following trials were conducted in the slush casting process. When the mold is inverted after 60 seconds. So they have given a time T1. I will show it by tau. Tau 1 is 60 seconds. And my dear, for the 60 seconds of pouring, the thickness of the casting produced. So thickness of the casting produced is 2.5 mm. This is the data for the first trial. Second trial says the time is 120 seconds. And the thickness will be 4 mm. Then you need to find out what would be the time required for the 6 mm. So I told you in the slush casting, whenever we are going to have, you know the Chvorinov's law. Solidification time is directly proportional to volume by surface area ka square. You know volume by surface area is thickness for the thin section. So this is solidification time is directly proportional to thickness ka square. So my dear, you can write the thickness is equals to C1 square root of solidification time. I am showing it with tau s plus C2. So this is the equation where C1 and C2 are the constant. You can also write this equation as T is equals to C1 plus, here T is the thickness, C1 plus, this is or C1, okay, C2 plus C1 root tau s. So my dear, first of all, you will put the data of the first one. So you know this is 2.5 thickness, C2 plus C1 square root of 60 seconds. The second equation will be, my dear, 4 mm thickness. It is C2 plus C1 square root of, then the time is 120 seconds. These two equations will give you C1 and C2. After that, you put the thickness value C1 root tau s plus C2. You need to find out the value of time for 6 mm thickness. So try to solve it, guys. Yes, Kiran, are you trying this? Yes, Kiran, are you trying this? So when you will be solving, you will get the value of C1 and C2. When you will solve it, you will get the value of C1 and C2. So if you want the value of C1 and C2, my dear, after solving the two equations, you will be getting the value of C1 and C2. Okay. So Kiran is saying the answer this time is C, 232.43 seconds. So my dear, I would like to say yes, your answer is correct. Because when you will solve it, you will get C1 value to be equals to 0.4675. And you will get the value of C2 to be equals to minus 1.1213. And when you will be finding out the time, you will be getting 232 seconds. So answer is correct, Kiran. C is the right answer. Moving to the question number 3, guys. This is from the permeability number. Very good, Kiran. Very good, Kiran. This question is from permeability number. This is from the permeability test. I feel you guys would be very easily giving the answer for this question. A sand specimen is made according to AFS standard and tested by using permeability test. I feel everybody aware permeability test is performed by taking a cylindrical specimen of diameter and height equal. And my dear, whenever we are having this diameter and height equal, you are going to allow the air to flow at some pressure difference. And my dear, then you find out the time required for the flow of that, because that will be giving you the proper idea of the permeability number. Is it clear, guys? Yes. Please solve this question. Yes, Kiran, I am expecting you will give the answer. And also they have given all the data. During testing, a time of 10 minutes has taken for bringing the 2000 cubic centimeter. So volume of air is 2000 cubic centimeter. Pressure difference is 10 gram per centimeter square. We need to find out the permeability number. Okay. So the formula for permeability number is VH by delta P AT. Time required to fill the cavity. This is TF. And my dear, I am telling you the diameter and height are 5.08 centimeters. So you can put the value directly because this H and area will be found out by this value. Okay, so they have given the volume of air that is 2000. 2000 into height is 5.08 divided by delta P is 10 into area is pi by 4 5.08 ka square into time is 10 minutes. You will get the answer. Kiran is saying the answer is 5.01. And yes, I feel the answer is correct. 5.0127 is correct. You will get answer to be 5.0127. So guys, my target is to take all the questions of different type. So you can see first was on shrinkage volume method. Second question was on slush casting. Third question is on permeability number. So that you get the taste of all the types of the questions here. So guys, we completed 3 questions. Today also we have 10 questions like yesterday we have. Now the question number 4 is in front of you. An aluminium casting. This is from the gating ratio. This is using the concept of gating ratio and also the gating system design. So this is going to use two concepts simultaneously. And this question says that an aluminium casting having gating system with gating ratio. You know what is gating ratio? Sprue area, in-gate area, sorry, runner area, in-gate area. 1:2:2 is designed for a discharge of 100. Discharge means A into B. 100 cubic centimeter per second. Maximum velocity in the gating system should be. So V maximum is given 10 centimeter per second. You need to find out area of gate. It seems to be very easy question. But let us see, are you able to give? Okay, Kiran have given the answer as 20. Very good. So dear, whenever you get this question, the first challenge is, okay, here I'm going to make a very important announcement. To make the class more attractive and to make it more useful for you guys, I am deciding that I will be discussing one interview question at the end of all the classes from tomorrow. So from tomorrow onwards, every class will have one interview question at the end. Okay. So just you get the advantage from tomorrow. Okay. And let us solve this question. So when we are talking about this question, the first challenge is to find out that where the velocity will be maximum. Whether the velocity is maximum at the sprue, at the runner or at the in-gate. So my dear, you can see the area is minimum here. So as the flow rate A into B is going to remain the same throughout, whatever will be coming out from sprue, the same will be going to the runner, the same will be coming from the in-gate. As all of that flow rate is going to be same, so it is very much fine that you will be having the maximum velocity for minimum area. So we are having minimum area at sprue. So my dear, area of sprue into maximum velocity, that is 100. So you would be having, my dear, the area of sprue as 100 divided by 10 is going to be 10 centimeter square. Then my dear, area of in-gate will be 2 times of the sprue area. Okay, why? Because this is from the gating ratio. So answer will be coming out to be 20. So 20 is the correct answer. Very good, dear. Moving to the next question. Question number 5. So my dear, if you see this question is related to the time required to fill the cavity from top and bottom gating system. The height of the down sprue is 175. Down sprue height is H1, 175 mm. And cross-sectional area at the base means in-gate area, 200 mm square. The cross-sectional area of the horizontal runner is 200 mm square. That is not required. Assume no loss. The time required to fill a cavity. Time required to fill a cavity needs to be calculated. And the volume of the casting is 10 to the power 6 mm cube. It looks like a problem of top gating system as down sprue is given to us. So I feel you guys would be aware of the formula. Time required to fill the cavity by top gating system is volume of casting divided by 2GHM, height of molten metal, into area of in-gate. And you know that HM is generally H1 plus H2. Actually, this should be H2 because height of pouring basin is not given. So H1 is 0. I feel now you can solve it and you can find out what was required, the time required. Yes, you need to find out time required to fill the cavity by top gating system. So just solve it, guys. Just solve it, guys. Okay, so answer is given by Kiran as 2.698. So yes, I would say the answer is correct. You will be getting the answer to be 2.698. Here, what kind of mistake students are doing is, they are not putting the value of G correctly. If you can see, my dear, the volume is given in mm, 10 to the power 6 mm cube. So here you have area of ingate as 200 mm square. So you need to put the value of G also in mm. So you will be having 2. In mm it is 9810 into 175. You will get the answer to be 2.69. That mistake you need to be aware of. Okay. Moving further, guys. 5 questions are over. 5 more yet to go. So do like and share the session, guys. This is question number 6. 4 more questions after this. For producing a casting of this size, a side cylindrical riser is used. Determine the diameter of the riser assuming the modulus of riser 20% higher. This is a question of the riser design. Question of riser design. But by which method? By modulus method. So modulus method says modulus of riser is 1.2 times modulus of casting. It is always more than or equals. If they do not give this, you will use this only. But if they give here 30%, it will become 1.3. So this is always like this. Modulus of riser is volume of riser, but area of riser. It is a side riser. More than equals to 1.2. Volume of casting, but is area of casting. So I feel you know that it is going to be 4. Okay, not 4. Pi by 4. Pi by 4 d square h divided by 2 into pi by 4 d square plus pi dh. This is the volume but a surface area of riser. It is 1.2 times. For casting we have 300 cross 100 volume. Surface area is 300 cross 300. 300 cross 100. 300 cross 100. This you need to do and you will get the answer very easily. Okay, no issues, Vinit. Now are you fine? Kiran is saying the answer to be C. Okay, 216. Let me check it. So the answer is 216. Very good. C is correct. So you will be having this answer to be, you need to find out what diameter of the riser. Very good, guys. So they have mentioned determine the diameter of the riser assuming that the modulus of riser is this. So as it is side riser, you will take diameter is equals to height. Because there is no other relation given. So we need to use it and you will get this to be 216 mm. Very good. Moving to question number 7. So guys, this 7th question is once again from the riser design, but this is from the Chvorinov's law. So every question is different. If you see in this session, I am taking all the topics covered with the questions. One topic, one question. One topic, one question. Okay. So here we have casting of size this. So if you say casting of size is given, you just need to apply this. Solidification time of second casting, solidification time of first casting is the ratio of volume but a surface area of second casting का square divided by volume by surface area of first casting का square. This is what you need to do, guys. Okay, so guys, do like and share the session. Still we are left with 3 more questions after this. So if you say they have given you many datas, TS2 needs to be calculated. TS1 is 30 minutes. Then you can say volume of both the castings 500, cross 400, 200. Surface area 500 cross 400. You will be having square of this 500, 300. Divided by 2 into you will be getting the value of TS2. Only calculations are there. This type of many questions have been asked. Okay. Vineet, this is very simple, na? Solidification time is given as K into V by surface area ka square. This is Chvorinov's law. K is the solidification factor. V is the volume. SA is the surface area. Okay. And if conditions are same, K will not change. So here for both the cases, conditions are same. So K will be remaining the same. So when you will solve it, the answer you will be getting it as 11.5 minutes. So Kiran have given the right answer. It is 11.5 minutes. Moving to question number 8, guys. This is for, my dear, parting line gating system. This is the question on parting line gating system. Parting line gating system. So all the questions are different. I am not repeating any question. हाँ बिल्कुल विनीत फिर के दिया हुआ होगा. So guys, this is a wonderful question which we are going to do. And this type of question we can expect in GATE exam. This is question number 8. After this we have 2 more questions. Okay. I will try to give you one bonus question also. So if you see this question, it is saying that a cuboidal casting of 30,000 centimeter cube total volume has to be filled with a parting gating system as shown in the figure. The height of the mold cavity above and below the runner plane are equal. So they are saying this height and this height are equal. Then you are having the total liquid head is maintained constant such that it is equal to the mold height above the runner. So they are saying the height of molten metal is also the same. Okay, guys. Okay, I feel you have given the answer. Let us see. If the runner has uniform cross section of 20 mm dia, the total time for filling the cavity is. Okay, Kiran, let us see. So I would like to tell you guys, these are the 2 parts, A and B. When the molten metal will be coming inside, my dear, then B will be filled by top gating system because molten metal is coming from the top. And A will be filled by the bottom gating system because A is filled from the bottom. So if you want to find out the total time required to fill the cavity, it will be equals to the time required to fill the cavity A plus time required to fill the cavity B. And my dear, you know, for bottom and top formulas are different. But whenever we have the heights to be equal, whenever we have the heights to be equal, which heights? This height and this height. If height of molten metal is equals to the height of cavity for bottom gating system, for bottom gating system, for bottom gating system, we are having this height and this height are equal. So for such cases, the time required to fill the cavity by bottom gating system is coming out to be 2 times of time required to fill the cavity by top gating system. So my dear, obviously this will be calculated by top gating system and this will be filled by bottom gating system. But this bottom is going to be equals to 2 times of top. So my dear, if you see, they are saying a cuboidal casting of this total volume has to be filled. Total volume is 30,000 and as height are equal. So you can say 50,000 volume will be here, 15,000 volume will be here. So volumes are equal. So obviously my dear, if you calculate the time required for this cavity, for A you just need to double that. So my dear, the answer will be coming of what? The time required to fill the cavity by total is equals to what? First of all, you will say it is equals to 2 times of top here and 1 time of top. Why they will be same? Because you know that the volumes are same for both and the gate area is also same for both. So velocity of the fluid will also be same for both, because when we are going to take this, you can write this directly as, okay, we are filling it separately. Let us say TF of A plus 2 times of TF of A. It will be 3 times of TF of A. So I feel you got the mistake. Now we are going to see it is 3 times. So guys, I feel for your motivation, Abhinav sir is also there with us. You can make heart sign for sir. Sir is always there to motivate you guys. And we are coming live on Thursday for a session. Like if a student is starting now, then what are the chances? This is going to be volume of the casting. And then it is area of ingate into the velocity. So when you will be putting this value, I feel now you can solve the answer. They have already mentioned. What is the question? Question says what? They have given everything. 30,000 total volume has to be filled. The height of the, they have given the height. You just need to apply the formula now. And when you will be solving it, what will be the answer you will get? The answer will be coming out to be what for this? It will be coming out to be 59.04. Is it correct? Yes, Kiran. 59.04 will be the right answer. 59.04 seconds will be the right answer. Is it clear for everyone, guys? This is question number 8. Moving to the question number 9 now. Moving to the question number 9 now. So guys, 2 casting of same material. 2 casting of same material have same surface area. So they have given that surface area of 1 is equals to surface area of 2. Fine. One casting is in the form of a sphere, other is in the form of a cube. So one casting is sphere. For sphere, surface area is 4 pi r square. For cube, it is 6a square. Then they are saying the ratio of solidification time for sphere to that of cube. So solidification time of sphere to that of cube. It is K into volume by surface area of sphere ka square. K into volume by surface area of cube ka square. KK will get cancelled out. You need to find out the ratio and you are given the radius and everything. So this ratio is given to us. So you just need to say what is volume of volume. Okay, surface areas are given equal. They will get cancelled out. So volume of sphere is 4 by 3 pi r cube. And it is volume is a cube. So you know the ratio of r by a from here. You can find out r by a is equals to 6 by 4 pi. R by A is 1 by 2. So you just need to put the value 4 by 3 pi. Obviously square will be there. 4 by 3 pi R by A is 6 by 4 pi to the power 1 by 2. And we are going to have their power 3 and 2, 6. So you will be solving this and get a answer. Yes. So what would be the answer for this question, Kiran? Vineet. After this, we have 2 more questions. Okay, Kiran is saying 1.909. 1.909 is the perfectly correct answer. Very good. 1.909. This is the right answer. So moving ahead. Very good, Vineet. Moving ahead to the question number 10. This question, you avoid the options. Take it like this is a numerical answer type question. This is from the exception. A grey cast iron. A grey cast iron. Casting is to be produced of size this, with shrinkage allowance of 2% and machining allowance of 2 mm per side. The volume of the pattern will be, because of due to machining allowance, 200 will become 204. 100 will become 104. 46 will become 50. Because every side you just need to add the 2 mm. So this is the desired size because of the machining allowance. And shrinkage allowance is given 2%. So generally whenever students see grey cast iron, they feel that volume of pattern will be smaller than the volume of casting because cast iron shows different behavior. But I would like to say cast iron is not showing that kind of different behavior. Whenever we are talking about the cast iron is whenever we are talking about solidification. Then my dear, this is the cooling curve. So my dear, for this stage, this is said to be liquid shrinkage. This is solidification shrinkage. This is solid shrinkage. And my dear, allowance is provided for this. For this third stage, grey cast iron shows the same behavior as other materials. But in this phase, cast iron shows different behavior. In this phase, it expands. So when we are talking about shrinkage allowance, this is not going to be affected. This will be affected for the riser design. In grey cast iron, you may not be required riser because whatever hair shrink, the same hair expansion happens. Okay. So there is a question Varun is asking, sir, which one is the good MTech in design or MS in IIT Delhi Mechanical? Please inform more about MS in Mechanical at IIT Delhi. Dear, obviously, when we are talking about the MS and MTech, I have taken a video where I have clearly told you in 5 minutes what is the difference between MS and MTech. Go for that video, or I will share that video in my Telegram channel after this class. It is available on the same channel. There in 5 minutes I explained the difference. Okay. But otherwise, obviously, students are preferring MTech rather than MS because MS is slightly more time taking. It is more on research based. Okay. So you can watch that session. But if you are talking about, if you are having the same option, design is always better for MTech, design is better than the MS you are asking. Okay. But it should be on same college I am telling. Okay. So guys, when you will solve this, you will say volume of pattern. So grey cast iron also shows the same behavior as far as shrinkage allowance is concerned. The behavior is different for the riser point of view because for these two stages of shrinkage, riser provides the molten metal. So when you will say volume of pattern to the volume of casting, when you we will find of this. The volume of the pattern is they are asking. Okay, volume of pattern they are asking. No? So you know that when you are going to talk about the volume of pattern, you will be saying obviously 2%. So this is going to be the size. So you are going to do what? 1.02 volume of pattern and volume of casting. What this ratio will be? This ratio will be 1.02. Okay. So you need to do this. Is it clear? So when you will be doing this, you will be getting the volume of pattern like what? So volume of casting, whenever we are talking about, so volume of pattern, you need to have this size first of all. After that, allowance will be provided on these sizes. So when you have this 204, that will be equals to into 1.02. That will give you this size. And then when you will find out, you will get the answer to be 1060800. I feel so. This will be the answer you will get. Okay. Are you getting C or D? Kiran, are you getting C or D? Please tell me that. Are you getting C or D? Please tell me that. Are you getting C or D? Please tell me that. I am once again telling you if you have any confusion. This is the size for machining allowance. After that, this 204 needs to be multiplied by 1.02. You will get one size. 104 also like this. 50 also like this. Then you will be getting the answer. So what are you getting, guys? Dear, A would be coming if you are not considering the machining allowance. A will be coming if you will not consider the machining allowance. Because here machining allowance is also given, na? Yes. Kiran, are we getting C or D? Are we getting C or D? Please tell me. So whenever you have this, first you will go for machining allowance, then you will go for shrinkage allowance. Okay, first machining, then shrinkage. C only. Okay, C is the right answer. C is the right answer. So we are moving ahead, guys, and those who have still doubt in this question, I am telling you, there was a question in 2008 and 2016 where they have given the grey cast iron and they have done like this only in the GATE exam. Because whatever the difference in the grey cast iron, that is in this stage, and shrinkage allowance is provided for this stage. So that is why answer will not be affected. This is the bonus question. Last one and bonus question for all of you. This is the bonus question, guys, for all of you. A side riser is to be designed for a hollow cylindrical casting of 50 mm inside diameter, 100 mm outside diameter. If the length of the cylinder is 50 mm, the diameter of the riser is. Here nothing is mentioned. You will go for modulus of riser is 1.2 times modulus of casting. A side riser is to be designed for a hollow cylindrical casting of 50 mm inside. So you can write volume of riser, surface area of riser, 1.2. Volume of casting, surface area of casting. Okay, I feel this will be d by 6, 1.2. Volume of casting is pi by 4, 100 square minus 50 square into height divided by 2 into pi by 4 plus pi d mean into height. Here this is the confusion. Pi dm into h you will take and you will get the diameter of riser. विनीत भैया, स्मॉल मिस्टेक को अवॉइड करना है तो मोर नंबर ऑफ प्रैक्टिस करो, क्योंकि जब आप एक गलती एक बार करोगे तो अगली बार उसको अवॉइड करोगे तो ऐसे करके सारी गलतियां छूटेंगी. तो एक बारी जब गलती करो तो प्रैक्टिस को छोड़ो नहीं, कंटिन्यू रखो. ठीक है, जैसे आपने पिछले क्वेश्चन में गलती करी, उस गलती को बाहर कर लो और थोड़ा सा ध्यान दो अगली बार टेस्ट देने से पहले कि पिछली बार कौन सी गलतियां हुई थी। अगर ऐसा करोगे तो अगली बार उन गलतियों से बचे रहोगे जो पिछली बार हुई थी। ठीक है, तो यहां पर जो है हम मीन डायामीटर लेंगे। वी विल टेक मीन डायामीटर फॉर द सेकंड एरिया and I feel you can solve it and get the answer. This is the last question for today, guys. And do like and share the session. And guys, what time you will prefer for tomorrow? Kiran is saying the answer to be 50. Kiran, check it once again. Some mistakes I feel you are doing because I feel answer will be 60. Ha, 60 is correct. Yes, 60 is correct. So guys, we are having options. We can have the session at 9 p.m. also. We can have at 5 p.m. also. And we can have at 11 p.m. also. These are the options we have. Because I have class from 6:30 to 8:30. So these three are the options. Tomorrow's topic will be metal forming and sheet metal operations. Tomorrow topic will be metal forming and sheet metal operations. Okay. Okay, fine guys. So I feel you got the answer as 60 mm. So here we will be leaving the session. I will share the PDF for my Telegram channel Mechanical by Dheeraj Sardana. So goodbye for this particular session. Thank you guys and stay tuned with us. बंद हो गई।